All right, so welcome to the Game Loops and Design Docs lecture. I'm Jasmine, and I'll be talking about game loops, and then later on, Kevin will talk to you guys about design docs. So first of all, some announcements. These are the labs due today. This lecture was also recorded quite in advance, so the announcements might have changed since then, so I urge you to look at the slides to stay up to date. All right, so getting into game loops. So we're going to go over game loops, feedback loops, arcs, and then we're going to talk about how to put them all together to make a fun and engaging game. So what is a core gameplay loop? As you can see on the slide, a core gameplay loop is a loop that cannot be removed without altering the fundamental nature of the game. So for Mario, this gameplay loop would be walking, running, and jumping. For Candy Crush, it's swapping candy positions. The objectives should be clear to the player. They can either be intuitively understood through gameplay or explicitly explained. So for Mario, the objective is to reach the end of the level, and Candy Crush is to make matches. Many games can have similar gameplay loops, but they feel distinct because of elements like level design. For example, when we look at Celeste versus Mario, on paper they have essentially the same core gameplay loop of moving and jumping, but the gameplay feels distinct because of different level design. So at its core, Celeste and Mario have very similar gameplay loops, but their gameplay loops are so simple and easily expanded upon that these games are taken to two very different places. A solid core loop should also be built on a concept that unifies your design choices. For example, Journey is designed around the idea of companionship. The core loop is movement, which the developers use to make the player feel alone as they wander through the vast desert. If the core loop was something like attacking enemies, this theme wouldn't be present. So the core gameplay loop helps communicate the theme and feel of the game. And lastly, a good loop should be compelling. The core mechanic should fully engage the player yet challenge them. You want to keep their interest piqued for as long as possible. And just a note, these aren't strict rules or a checklist to making your game loop. They're just some guiding concepts to creating a strong loop. Alright, so let's try to analyze some of Breath of the Wild's games loops. Of course, this isn't a live lecture, so we can't communicate. So I'll just give you what I think are some of the core gameplay loops of this game. So at its core, I think Breath of the Wild boils down to just moving, attacking, and collecting. The final objective is to defeat Ganon, which is told to the player pretty explicitly. And the core gameplay loop of just moving, attacking, and collecting is so simple that it's easily expanded upon. For example, for moving, you can explore new enemy camps and villages, and you can have dynamic terrain like rain, snow, and storms. For collecting, you can collect items, but also armor and weapon upgrades, and you can use those items in cooking. And for attacking, Breath of the Wild also has a weapon durability system. So all of these components added together, in my opinion, contributes to the theme of exploration. Of course, this is just one interpretation of Breath of the Wild's game loops. Now moving on to feedback loops. So feedback loops determine how the game reacts to player progress. And there are two main feedback loops, positive feedback loops and negative feedback loops. So positive feedback loops are when the player does something well and the game rewards them. This is common in a lot of RPGs, where if the player defeats an enemy, they get experience. And with experience, they can level up, get stronger, and defeat more enemies. Of course, the problem with this is that the game can quickly snowball, because as the player grows stronger and stronger, they'll defeat enemies quicker. And then, the cycle continues. So how a lot of RPGs balance this is by making enemies stronger as you get further into the game, and also increasing the amount of experience the player needs in order to level up. Positive feedback loops can also work in the other direction, where if the player does poorly, then the game will get more difficult. You can see this in chess, because if you do poorly and lose your pieces, then it'll be harder for you to come back because you have less attacking opportunities. This is also dangerous because if you use it too often, if you use the positive feedback loop too often, then you can end up in a situation where the player has no way of making it back once, it's a snowballing effect in the reverse direction. They just keep losing and losing. On the other hand, we have negative feedback loops. So it's basically the opposite of a positive feedback loop. If the player does well, then the game punishes them or increases the difficulty in response. And on the other side, if the player does poorly, then the game becomes easier. You can see this in Mario Kart. If you're in first place, then the items you get from the mystery box are a lot worse. And if you're in last place, you get bullet bills and stuff. And in first place, you can even get blue shell. These loops stabilize the game, but you also have to be careful of overusing them because it can send the player the wrong message. For example, if the player does well in the game but is constantly punished by difficulty increases, then they might think the game isn't very fun or start throwing or doing poorly in the game in order to make it easier on themselves. So from this, balancing your feedback loops is important. All right, and now just an example using Hades. The Hades is a roguelike where you kill enemies, and if you get further into the level, you can get more darkness, which is a reward that you can use to upgrade your skills, such as giving yourself more ammo or more damage. However, the game doesn't get harder as you get more darkness. The enemies deal the same amount of damage, etc. So you can see how this can quickly snowball out of control. You can quickly become overpowered. So how Hades balances this out is by using a negative feedback loop. They introduce the Pact of Punishment, where you can make the game more difficult on yourself by increasing player damage, attack speed, and even giving bosses new abilities. In this sense, the Pact of Punishment acts like a player-controlled negative feedback loop. If you're doing well in the game, you can choose to introduce new challenges in order to keep the gameplay balanced. The message here again is that positive and negative feedback loops are both useful in rewarding the player and maintaining balance, but you gotta make sure that you don't overuse both of them and just keep them balanced. Moving on to arcs. Arcs have similar elements to a loop, but aren't built for repeated usage. An arc is essentially an interaction that can help the player build upon their mental model of the game. But unlike a loop, an arc exits after it's finished, so you don't return it to it. The best example of an arc is a cutscene. Cutscenes can tell you a lot about the story or mechanics of a game, but you don't go back to the cutscene after you've finished it. Arcs are a great way for conveying lots of information. So how do you structure loops? Here are some common ways to construct them. Sandwiches are when you move back and forth between cutscenes and gameplay. These are often seen in narrative games as they help convey a lot of information while breaking that information with gameplay. Another example of loops is parallel loops, where you use loops in music to supplement events in gameplay. This is used in Transistor, which is also made by Supergiant. And in Transistor, there are 3 channels to the music: vocals, percussion, and the rest of the music, so the instrumental part. When you're walking around in the level, only the music channel is playing. When you enter a battle, however, the percussion channel is unmuted, and suddenly the same music gains a sense of urgency, which supplements the gameplay. So continuing on how you build your loops, the figure on the right is a good representation of how higher level loops build off of lower level loops. It uses Breath of the Wild as an example. So as we talked about before, the core loop of Breath of the Wild is at the top, right here, where you walk around, attack, and collect items. The secondary loop is 1 level higher than that, and it could be collecting monster parts, finding armor, and finding fairy fountains. And the tertiary loop, even higher than that, could be completing all the side quests, unlocking all the areas, like finishing the map, and collecting all 900 Korok seeds. So notice that the core loop of the game has a minute-to-minute timescale. The secondary loop has an hour-to-hour timescale, and the tertiary loop might take quite a few days or even weeks to complete. This helps keep the player engaged for longer. It also adds depth, since the player now has to consider multiple goal levels in their decision-making. They have multiple different loops that they can choose to progress on at any stage of the game. So having these higher level goals adds more depth and interest in your game. Alright, so in summary, remember to design a solid core gameplay loop. And things to keep in mind when you're designing your gameplay loop is to make sure it has a clear objective, it's compelling, thematically cohesive, and easy to iterate upon. Be mindful of what feedback loops you're implementing, whether they're positive feedback loops or negative feedback loops, and make sure that you balance game progression. Make sure that the game doesn't snowball out of control and you're not punishing the player too much or sending mixed mixed signals. And remember to structure your loops effectively to maintain engagement. And of course, keep these ideas in mind, but don't be afraid to experiment and change up the form. These are just guidelines to making a good core loop, but of course, game design is all about experimentation, so as long as it's fun in the end, it'll be a good loop. Yeah, that's all from me. I'm passing it off to Kevin, who will talk to you guys about design docs.
Hey everybody, it's Kevin and I'm here to walk you through the second part of today's lecture. So for my part, we will be talking about design docs. We will be going through what a design doc is, how a design doc is useful, a design doc outline, tips for making a design doc, and what a feature list is. So first things first, what is a design doc? A design doc is basically your entire game on paper. This is how the game will be developed, and the game should be able to be created by someone else using this exact same design doc. Design doc is normally created before, it should be created before, the actual process of making the game, and it describes the how you will be making the game, how it will look. It answers all of the how questions that you should probably have in mind when creating a game. Now, a design doc doesn't need to have everything answered. And that's because things change over time, and you might not have a clear idea about what you want right now. How is a design doc useful? A design doc is useful because it makes sure that you are on track. It makes sure that you can get your MVP, or minimum viable product, which is to say the least amount of things that need to be completed so your game can be considered a game. If you can get this done, then you can consider your design doc a success. Now, we will be using MVPs a lot in this class. We will be using that term a lot because we expect you to have a completed game. And a design doc is useful for that because if you ever get lost somewhere in the way, you can make sure that you're on track, that you're hitting your dates and you're making the deadlines that you set for yourself, which goes on to make sure that you're on time. Going back, keeping track of the original plan. You want to make sure you're hitting the ideas that you wanted to hit, and you want to make sure you're doing this on time. Because your ideas might get off track, in which case you look at the design doc and bring them back onto track, and make sure you're reaching the right conclusion at the right time. It's good to record. A design doc is useful so that you can record the changes and they can be remembered amongst the entire group. Typically, you might come up with a change for your game in the middle of the day, say. Sometimes things just come to you. It's important that you have a place to write those changes down so that when you're actually creating the game, you don't just forget them and forget this amazing idea that you had. You could also realize that something needs to be cut, which is the next piece. In the middle of the game design process, you might figure out something is off. And if you figure out that something that you originally implemented is off because it doesn't fit, then you should probably cut that. And it's okay to cut things because it shows that you realize that your game didn't need it. And it can also make your game a lot better because sometimes too many things can make the game too cluttered and confusing for the players. The design doc also shows how each aspect of the game fits in together. You don't want your game to be a cluttered mess where nothing makes sense, where it's a mix of puzzlers and a shooter for some reason, and you could phase through walls, but it's never really explained how. Maybe your game has all these things and it explains it beautifully, but if your game doesn't explain it very well or it doesn't really fit in with the theme, you should probably take it out. But this ensures that everything in your game makes sense and fits together like a nice, beautiful puzzle piece. It also makes sure that everyone is on the same page. Sometimes you might talk things out verbally and have made decisions, but if it's not on paper, people are going to forget and nobody's going to be on the right track. This is why a design doc is useful. It keeps you on track, it makes sure everyone's on the same page, and it lets things easily be changed for the future. Now, the outline for a design doc that we are expecting from you is that you have a description, an objective, general theme, mechanics, aesthetics, a feature list, a division of tasks of some sort, a schedule, and anything else you might need. Now I'm going to be working my way from the top to the bottom of these features. Now, objective. This is just a short sentence about what your vision for the game is. What do you want to get through with? What do you want the game to show? But just really short. Now, the description has the general gameplay loop, what is going to be the main mechanic of your game, important components, what needs to be added to the game to make it complete, and more elaboration on the mission. What emotions should the game invoke? What details do you need for the game? Why do you want to make this game? What should it look like, more or less? The genre and theme. This is whether your game is a 2D or 3D or 2.5D, if you want to go that way. The genre, as we all know, whether it's a roguelike, a puzzler, first-person shooter. And then the theme. Is it light and fluffy? Is it dark and edgy? What kind of emotions do you want to invoke from the person when they see your game? How do you want it? The mechanics of the game. This, as we all know, is a very important part in making a game. Going back to game loop and the cycles, what are people going to be interacting with a lot? What are they going to be using a lot? What's going to make it interesting? Should the player be able to jump? Should they be able to push objects, not push other objects? Do they need items? These are the mechanics that are going to be needed for your game. Aesthetics. This connects back to theme. How do you want it to look? How do you want it to feel? More specifically, you want some maybe concept art here. You can put images here. It's really good to put like a color scheme that you expect, or what you want the player to look like or feel like when the player sees the actual character model. Now, a feature list is something we'll get more into later as for the slides, but basically this is a more specific version of the mechanics. The division of tasks. Who is going to do what? What feature is everyone responsible for? You can't have all three programmers programming the control scheme for the player, because then you might end up having either 3 different control schemes or a giant mess that nobody can really understand because everybody's been working on the control scheme for the player the whole time. And it's also very inefficient. If everyone's working on the control scheme, who's going to work on the enemy? Who's going to work on the puzzles? You need to make sure that everyone knows what they're going to be working on. Which brings us to our next point, schedules. This is what's going to make sure that you stay on time, that you meet your deadlines. When should this mechanic be done? At around this time. Then as soon as you finish that mechanic, could you please start working on this mechanic? It makes sure that everyone's pushing their goals properly and that your goal is achievable. Now for others, you could really put anything else that doesn't fit in the other sections here. In my group, we had something called Word Vomit, which was basically just what we wanted for the game, personally. And it actually helped us influence some of our other top categories, such as genre and mechanics. Now, in a more professional game design document, they can include things like the control system, the control layout, what platforms they want to be on, how they're going to monetize it, player UI. They'll go into a lot more detail of that and how to optimize these things. But we're not expecting this from you right now. Tips for making a design doc. You want to build your design doc in stages. You're not going to have a clear idea of what you want it to be in the beginning, so we just want concepts. We want stuff to get our minds thinking and just to get us started on the right track. By the middle, experiment. Once you have enough of the game implemented, or a certain amount of the game done, you can add things in. Experiment. Hey, I was thinking maybe we should have a block that could be pushed on a button. Might be simple, maybe you guys haven't implemented yet, maybe it doesn't go with the theme. Just experiment. At this point, it's fine to try almost anything as long as it meets your time. Now, by the end, this is where you need to stick to your objective clearly and defined, and have it be defined. If near the end you can't be making changes, because then you're going to be having 20 different things that you weren't able to implement because you were too eager to add things. At this point, you should stop adding things and stick to the design doc as much as possible. Now, the building in stages flows right into allowing the doc to change over time. Like I said, you're not going to have a clear idea about what your design doc is going to be at the very beginning, so, give it some room. Allow it to change. Maybe you realize that the theme doesn't match your gameplay. That's fine. Change the theme, change the colors a little bit maybe, or rethink your gameplay, especially if it's early on. Of course, you want to be careful with this because the further into the project you get, you might want to lower the amount of changes you're making because, again, you don't want to get overwhelmed with 50 changes that you need to make within the last week. Now, preferably, you would want one person to be in charge of the doc. This is the one person that adds things, is always open to suggestions from anyone in the group, but is the final word. Now, we will be looking at an example from my game that I submitted last semester. First, I want you to see the game for some of the gameplay so that you can get an idea about what we're going for. And my computer actually doesn't run this game very well, but that shouldn't be a problem because most of the things I want you to see aren't from how fast the game actually is. Here's one of our mechanics, double jumping. And then here's another, moving platforms. And this windmill is to signify the end of the level, but I'm going to skip that for now. And we have spikes. I'm going to skip a little bit more because the character is moving so slowly. But as you can see, the levels change a bit over time. The colors in the background change over time. And we end up getting to this urban area. I'm just gonna skip through the rest of these levels just to show what they look like. Cool. And now we're gonna take a look at the actual design doc. This is the design doc that me and my group have. You can see we have a very simple mission statement here, a single player game. There's a strong emphasis on movement, cyberpunk dystopian aesthetic. I think we hit all of the points that we wanted here. And then we have a much longer description. Lasers, 2D platformer, spikes, and so on and so forth. We then have the mechanics, WASD moving for the MVP, sprinting, ducking, sliding. We didn't get to add all of these things in, which is just to show these are added goals that we wanted to push for if we ever got to it. Our genre, such the platform, the fact that it's a platformer, our aesthetics, the feature list. We started with a few items and we pruned it. Here's our division of tasks. We used a spreadsheet. You can use whatever you feel is best. And then here's this other section I wanted to talk about, the word vomit. You can see we all had our own ideas. Now, when I was back in the game, I did mention that the background was changing, and that goes in our aesthetic. We wanted the story to be that you were trying to escape from this dystopian world, and you went from a high-tech civilization to more of a foresty location as you tried to escape. And this was the project that my group decided to work on. Now we're going to continue on and move on to the feature list. Now the feature list has the components that I was talking about before, the main game loop, a basic story, added mechanics, and enemy types. As an example, I'll use Mario. In Mario, the main game loop, in my opinion, is running and jumping. That's the main thing he does. He runs and jumps to get to the end of the level. Basic story, the princess was taken. Can't get any more basic than that. Added mechanics, the fire flower, the 1-up, the coins, the mushroom, all of these are added mechanics into the game to make it more interesting, more fun. And lastly, enemy types. Goomba, Koopas, flying variation, and Kamek, and bosses. We all know Mario. This is basically what a feature list is. Now, how do you create a feature list? A feature list should be decided as a group, and you want about 3 or 4 features that you feel like are necessary to make your game complete. You would then want to break these features into 3 to 5 sub-features, just so you can get them down to each little piece that makes the feature what it is. And then decide on how important each of these features are. Each member can rate them individually, and then you can combine all of the rankings to see what everyone thinks is the number 1 most important feature, and then work your way down from there. It's good to rank these so that way no one feels like their opinion isn't validated. And if there's too big of an outlier, you can all talk about it and re-rate these later to see how everyone feels about that. Ranking is also really good for scoping. Scoping is basically making sure that you guys aren't thinking too big. Again, it has to do with the MVP, the minimum viable product. If you're scoping too big, then you're going to have a lot on your plate and you're not going to be able to finish making the game. So you want to make sure you're focused just right to make the best game you can with the time and skills that you have. And that's all for this lecture. Thanks for joining us.